Hello dear learners, welcome to our video tutorial on the Quicksort algorithm, one of the most efficient sorting methods used in computer science. Sorting plays a fundamental role in organizing data, and Quicksort stands out for its speed and simplicity. In this video, we'll dive deep into how Quicksort works step by step to efficiently sort a sequence of elements, providing you with a clear understanding of its inner workings and practical applications. So let's get started and unravel the magic of Quicksort. So here is a sequence which we are going to sort in this video. Our first element is 17, 10, followed by 25, 27, 20, 28, 36, 25, 34, 44. If you already know about Quicksort, how Quicksort algorithm works, it's your duty to first of all copy this problem and solve it by your own. If you get any doubt, then see this video. Otherwise, skip this video because this video is going to solve this problem and make you a clear understanding of how Quicksort algorithm is used to sort an unsorted sequence of elements. You can say unsorted array also. Okay, so how we are going to sort? Let's see this. Simply first select the first element of any sequence as the pivot element. Also mark it as ith element, and the last element of any sequence you have to mark it with J. Also mark the first element as L and R. This L and R, we are going to change its value during our process. Okay, so let's see what you have to do. You have to check is R, here I am writing, is R smaller than or equal to the pivot element. Okay, the most basic is you have to first start with this. If you know this condition, how to implement this algorithm is simple for you. You do not need to do any other thing. Okay, you see, you check is R smaller than or equal to pivot element. Yes, then is smaller than 17. What you have to do, listen it carefully and fit it in your mind because this is very useful for yourself. If R is smaller than or equal to the pivot element, you first increment L, okay, like this. And what you're going to do next is you simply swap the value of L and R. Since here L and R are same, if you swap L and R, doesn't happen, means it will not do anything. Okay, so after swapping the values of L and R, you simply increment R by 1. Okay, then what will you do now? Another, in this also you check is R smaller than or equal to pivot element. If yes, then you will increment L and swap L and R. In this condition, R is greater than the pivot element, so you do not need to increment the value of L and do the other process that I have told you in the beginning. You simply need to increment R and do not need to do anything else. Okay, again you check is the value of R is smaller than or equal to pivot element. Always check the pivot element. Okay, now 27 is greater than 17, so what you're gonna do is simply increment R. Again check is R smaller than or equal to the pivot element. Our pivot element is the first element of the sequence, which is 17, so 20 is greater than 17, so simply increment R. And again check Is r smaller than or equal to pivot? Nope. So you gonna increment the value of r by 1. Again check, is r smaller than or equal to pivot? Nope. Again increment r, and again check, is r smaller than or equal to pivot? No. Then again increment and again increment, because in this case also r is greater than pivot. Now what to do next? Because r has reached the last element of the sequence. In this case r is equal to j. If this happens, you simply swap pivot element and L element. Okay, like this. 10 will come here and 17 will go here. Yep. So swap pivot and L and write it as L means 10 will come on the first place and 17 will go on the second place, and the remaining element will be written simply as it is written in the beginning of the problem. Okay, so this is like this. Okay, so whenever pivot changes its position, remember one thing: whenever pivot will change its position, pivot element will change its position and go to some other position, that position will be its perfect or the proper position. So we do not need to change the position of this element anymore in the rest of the problem. Okay, 17 has reached its proper position, which is the second place. It will remain at second place throughout the solving process of this problem. So now see, to the left of the 17 there is only one element, and to the right of 17 the rest of the elements of the sequence is like this. Means the given sequence is divided into two parts. The two parts are the left part of 17 and the other part is the right part of 17. So here is only one element, means in the left of the 17 there is only one element. So we do not need to sort this anymore, because single element what you will sort. Okay, you do not need to sort this. Now you need to sort the rest of the elements, which is in the right of 17. Again apply the same process that I have told you in the beginning. Means you choose the first element of that part you want to sort as pivot element, mark it as I. Also L is equal to I, and the second place element as R, the last as J. Now do the same process. Compare, is R smaller than or equal to pivot? No, 27 is 2 more greater than 25, so simply increment R. In this case see, is R smaller than or equal to 25? Yep, 20 is less than 25, so you change the place of L and swap LR. Okay, now you will write this sequence as this: 25, 20 will come here, 27 will go here, 28, 36, 25, 34, 44, and by doing so you increment R after doing this. So R will be here, L will be here, L will not change its position, IJ will be same, pivot element will be same. Now check, is R smaller than or equal to pivot? No. Increment R, is R smaller than or equal to pivot? No. Increment R, is R smaller than or equal to pivot? Check, in this case R is not a smaller than 25, but R is equal to 25. Means one condition is satisfying, that R is equal to 25. Do the same thing, increment L and swap the values at the position L and R. So 25, 20 25 will come here, and 28, 20, 36 and 27 will go here. 34, 44, R will be incremented, means R will reach as 34, and L will be here only, and I, J, and the pivot element. Now check, is R smaller than or equal to pivot? No. So increment R. R is equal to J, means we have reached the last element of the sequence which we want to sort. So what we'll do now, we will swap pivot and L. Okay, so 25, 20, 25, 28, 36, 34, 44. Here again, if pivot is changing its position and going to the position of L, so pivot element has reached the third place of this sequence only. So pivot has reached its proper position. Pivot has reached its proper position here. Okay, I hope you have seen this. If you did not seen this, now you can get it from here. Okay, and the rest of the element that we have sorted will be copied like this. Okay, so this, yep, 25 has reached its proper position, 27 has reached its proper position. Now to the left of 25 there is 2 elements, to the right of 25 there is 5 elements. We need to sort both left and right, because computer does not know that 25 and 20 simply means, okay, smaller than or equal to, you know this, not 20 will come here and 25 will go here, but you have to perform the same process that you performed earlier with the bigger sequences. First of all, we solve this one, then we will jump into this. Okay, so 20, 17, 25, 20, we'll be leaving this right now and making this element as pivot. I, L, 36, 27, 34, 44, last element is J. Okay, now check, is R smaller than or equal to L? No, in this case, so I've incremented already R with a value of 1. Okay, now check, is R smaller than or equal to pivot? Yes, because 27 is 1 less than 28. So you change the value at, means you change the place of L. And what you will do now, you swap L and R and write this sequence as this. At the place of L you will write R, and at the place of R you will write L. Okay, this element is pivot. Okay, and you increment this also after swapping. R reaches here, L is here only. Now check, is R smaller than or equal to pivot? No, simply increment R. Again R is greater than 28, means R is greater than the pivot element, so we do not need to change the place of L and swap. Okay, now R is equal to J at this point of time. So what you gonna do is you swap pivot and L element, and wherever 28 will go, means wherever pivot element will go, the pivot element make the element at its proper position. Okay, so 28 will come here, 27 will come here, 36, 34 and 44. 28 reaches its proper position, and the rest of the sequence will be written simply as it is. Okay, 7M, 25, 20, 25. Remember, we do not perform the sorting at the left of 25. Okay, we have to do it. Now we have seen we are at the left of 28 there are 3 elements, and at the right of at the left of 28 there is only 1 element, and at the right of 28 there is 3 element. We need to sort this, and also this need not to be sorted as this is a single element. So what you will perform, okay, so sort it also, and at the same time sort it also. This is not a big problem, so we can perform it with one go also. It will make your understanding easier. Okay, so do see, is r smaller than or equal to 25? Yes. So increment L and swap LR, and R is equal to J also. So what you're gonna do is you simply swap pivot and L element, and 25 will come here, 17 is here only, 20 will come here, 25 is its proper position, and 28 is already on its proper position, 20 is here, it is on the left of the 25 which has already reached its proper position. So 20 need not to be sorted at all. 27, 28, is r smaller than or equal to L here? Yeah, so simply increment L and swap L and R. You will swap L and R. L is equal to R, so need not to be swapped. Simply increment R. Check is r smaller than or equal to L now. So R is equal to J also, means R has reached the end of the sequence you are sorting. So you swap pivot and L element. So 36 will come here, 34 will come here, 44 will come here, 36 has reached its proper position. Now see that on the left of 36 there is only one element, and on the right of 36 is only one element. They need not to be sorted, means here is no any sequence left. We reached the result as this: 25, 25, 27, 28, 34, 36 and 44. This is the sorted sequence with the help of Quicksort algorithm. See how easy is this. If you have any doubt you can post it in the comment, but I think no any doubt has left. I have explained it very slowly with a simple word. I do not use any difficult words here. Okay, so in case you have doubt left you can post it in the comment. I will definitely reply to you. But I think sorting is easy in the computer science.